A permutation is an ordered selection of elements taken from a given set. You can use the concept of permutation if you want to find all possible ways of ordering a certain number of objects. Example, you're trying to put 3 children represented by A, B, and C in line for a game. How many different orders are possible? So we're going to use what we learned previously to figure out the number of possibilities, which is a tree diagram. So I'm going to draw a tree diagram to show all the different possibilities for how I can line up 3 kids for a game. So let's draw the tree diagram. So in the first scenario, I can select A, so child represented with A, child represented with B, or the child represented with C. So this is the first scenario. Now, I cannot select A again because they've already in the lineup. So in the second scenario from here, I can select B, or I can select C. So if I selected B, I can select A or C. And in the last scenario where I selected C already, I can select A or B. So that's the second person in line. In the third scenario, there's only one person left. So I have to choose whoever's left over. So A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, or C, B, A. So that's the third time. So now I have all these resulting orders. I have ABC, ACB, BAC, BCA, CAB, and CBA. So there's six possible arrangements. So that's great. We drew a tree diagram and we managed to get the number of possibilities. We know there's 6 different possibilities. But imagine you actually had maybe 12 elements to choose from and you were trying to figure out the order. That would be a pretty big tree diagram. So that's where the permutation formula comes from. So I will show you what the formula is, and that will be a shortcut to actually get the resulting order, or the number of resulting orders. So before we do that, I'm going to show you the formula. And here is the counting technique called permutations. So again, permutations are for when order is important. So that's the key to remember here, because we will be learning something called combinations where order is not important. You're just trying to find out the number of ways, but the order is not important. Here the order is important. So one thing we do need to know before we get to the formula is this symbol here, which is called n factorial. You might have seen it in a previous course, some of you might not have. And basically it stands for n times n minus 1 times n minus 2 times n minus 3, all the way until you get to the number 1. So for example, if I think about the letter 6, the number 6, sorry, 6 factorial is the same as 6, and then times 5. So you're always going down until 4, and times 3, times 2, times 1. You always stop at 1. You should be able to find this factorial button on your calculator as well, which you can use. Okay. Then there's another formula called PNR or NPR. That's another permutation formula. Oops. Meant to highlight that. So there's different forms of writing this formula. We're going to show you how it's used in this lesson. And it's read as N permute R. Again, this formula permutation is used when order is important. Okay. NPR represents the number of permutations possible in which R objects of a set of N different objects can be arranged. Okay. This is used when, for example, let's say you had 10 children and you only want to select 6 to be in a lineup. Then you'll know how many different ways that's possible. So the formula is here. You're required to know this formula. It's n factorial over n minus r factorial. So the exclamation mark is a factorial. So let's see how this is used. So here we have six permute 4. This means there are 360 ways of ordering objects taken 4 at a time from a set of 400 for 6 different objects. So here you see an example why we wouldn't draw a tree diagram. So if I had to draw a tree diagram for this 6 permute 4, I would have 360 results. Okay. Showing you how this number came about is with the formula. Again, you should be able to find this permutation on your calculator. Please make sure your calculator has this function. Depending on what you're told on a test or a quiz, you might be using your calculator or you might be using the formula. So you can write it like this. We have 6 objects, they're different, and we want to select 4, and different orders are possible. Or you can see it like this. Using the formula, this would be 6 factorial over 6 minus 4 factorial. Okay. Which is equal to 6 factorial over, because this is in brackets, we can simplify that, 2 factorial. And this is the same as we saw earlier, 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. Cross these out because they overlap. And your answer is 360. Take a second and try and punch this into your calculator. Make sure you get the same result. Make sure you know how to use your calculator. So now we're going to look at different types of questions that would lead us to use this permutation. So example 2, a computer file can be given an 8-letter name. In how many ways can such a name be signed if there are 26 letters in the alphabet of the alphabet and no letter can appear twice? So we're not repeating any letters, so keep that in mind. So let's think about this. We have 26 letters and we're trying to choose 8. So now the order is important because we're actually assigning a name. So if you can't mix up letters, you'd have a totally different file name. So 26 permutes 8s. Okay. So this is the same as 26 factorial over 26 minus 8 factorial. Again, this is in brackets because that would simplify to 26 over 18 factorial. And if you were to calculate this, you can use your calculator and plug this in. You can work it all out if you want. I recommend, it's quite a number of different ways. So again, this is why we wouldn't always want to draw a tree diagram, because this is 6.29 times 10 to the 10. That's the number of ways a file name can be given an 8-letter name. So a computer file can be given an 8-letter name from the 26 letters of the alphabet. .29 times 10 to the 10 ways. Again, think about why order matters. We're talking about a name. The order letters will mean a different pronunciation, a different typing. Another example. The student council office has to be occupied for 4 hours each day by members of the council. If the council contains 7 people and 4 of them are each required to be present for 1 hour, how many ways can the daily shift be assigned? So we have 7 people, 4 of them are required. The schedule is important. You want people to show up for their hour. That's why order is important. So you do 7 permeate 4. You can also write it out like this. Both mean the same thing. Type this into your calculator and you would get 840. So there's 840 different ways. So the shifts can be assigned different ways. Now I'm going to open up some different unique scenarios. So here we look at letter arrangements, determine the number of letter arrangements that can be made using the letters from the word bird. So there's 4 letters here. So if I wanted to shuffle them up, that's the same as 4p4 because I'm using all 4 letters, which is the same as 4 factorial, which if you did that, it's 4 times 3 times 2 times 1, which is 24. Banks, now we have 5 letters. That's 5 factorial, which is the same as 5 times 4. So you have 5 letters and you're selecting all 5. That's why it's 5 permute 5. You're not only selecting some of them. Look at the jump from 4 factorial to 5 factorial. So the more you have to choose from, the larger the number of possibilities. Now let's look at B. You would think it's 3 factorial, but it's not. And let's look at Y. Let's try and think about all the possibilities. We have BEE, EPE, EEB. Okay, if I flip the BE, EE, so if I flip that, does that any different? No. If I flip these, the E and the B, E, flip those, is that any different? No. And if I flip those E's, they're no different. So really I only have 3 different selections. Whereas if I did 3 factorial, it would equal 6. So how do we get that? It's from a formula, which is on your sheet. So anytime we have duplication, so we have here we have two e's. So what I would do is do 3 factorial, because there's 3 letters. And I divide out by the duplication. So I have 2 e's, so that's 2 e's. Okay, and that's where this formula, that's where this formula comes from. Okay, so let's look at some more examples. So I'll do example 5. Determine the number of 8-letter words that can be made from the letters in the word fantasia. So think about it. I have 1, 2, 3 A's. So I have duplication here. Any other letters that duplicate? So that's it. So I would take that there's 8 letters. And divide it by the duplication. So those are the 3 A's. So 8 factorial divided by 3 factorial is 6,720. So that's how many ways I can rearrange the word fantasia. Before I go to example 6, I'm going to do another example like this, which is example 7. So in how many ways can the letters in Toronto be arranged? So again, I have 1, 2, 3 O's. And I have 2 T's. So I have some duplication. So if I rearrange those T's or the O's, there's still an O, there's still a T. The word would not be any different. So what I do is I count the letters as 1, 2, 3, 4, 5, 6, 7. So it's 7 factorial. And then divide out the 3 O's. So it's 3 factorial and the 2 T's. And 2 T's. And this will be 420 different. So now I'm going to look at lockers. So I'm going to go back to example 6. So suppose your school will be installing new lockers. Each locker is to have a unique, so that means we're not going to repeat the numbers, 4-digit number, tag attached to the door. How many different 4-digit numbers are possible if digits cannot be repeated? So let's start with that. So assuming that I can use 0 first, I would have 10 possibilities. So it's from 0 to 9. So I'm going from 0 to 9 as my first digit. I can have 10. Then I would have 9. Then I would have 8. Then I would have 7. So that's 4,000. Oops, that's not right. So think about it. The first time you select 1, you have 10. The second time you select 1, you have 9. Third time you select 1, you have 8. And fourth time you select 1, you have 7. So that's 5,040 different possibilities because you're selecting 4 numbers. So now if digits can be repeated, it's a little different. So making the same assumption, the numbers can be repeated. That I can start with 0. Okay. Then I would have 10 the first time. And now I can repeat the number I used the first time, so I can have 10 again. I can have 10 again. And I can have 10 again. So I have 10 to the 4 possibilities. Or 10,000 ways. I'm just going to add a little twist to this. So let's assume, I want to make an assumption, another assumption. Let's assume that you can't use 0 as a beginning number, because then usually we don't have 0 beginning, starting off. So I'm going to make another scenario, just to add a little twist. Then you would have 9 to choose from the first time, because I cannot use 0. The second time, I've used a number, so I have one less, but now I'm including 0. And then I'm going down to 8 times 7, and that would be 4,536. In this scenario, we can repeat values, so it would be 9 the first time because I cannot use 0, but the second time I have all 10 digits, and the third time I can use all 10 digits, and the fourth time I can use all 10 digits. So if you think about these values, each time what you're doing is here you're reducing it because you've already selected one and we're not repeating. If you can repeat every time you have the same amount to choose from, we add a little twist here. And the last question. 3 people are required to clean the cafeteria after lunch, 1 to clear the tables, 1 to sweep, and 1 to collect the garbage. Determine the probability that you and 2 friends will be chosen for the job if 3 people are randomly selected from our classroom of 15 students. So we are doing probability now. So you want the probability of you and 2 friends are selected. So that would be the NA over NS. So NS is all the possibilities. So all the different possibilities of selecting 3 people. So that's 15 permute 3, which is 2,730. And this is all the possibilities in which the orders that you and your 2 friends can be chosen, which is 3P3, because you can be selected first, second, or third. What matters is that the 3 of you are going. This can also be written as 3 factorial, which is 6. And you reduce that, or you turn it into decimal, so it's 0.2%. Oops, sorry about that. That's permutations, so it's all about the number of different ways that objects can be ordered. There's some different types of scenarios. And in this lesson that you should pay attention and review, and you should also keep in mind that with permutations, order does matter.